So hello everybody, thank you very much to invite me. So I will present our inputs for RTE, but let me first present who we are in the energy transition. So we are the French public electricity transmission network. And we optimizes the French electricity system by combining efficiency, solidarity, and environmental consideration. We drive the energy transition through innovation and the transformation of the grid, and we use its expertise to inform decision-making by public authorities, as well as the choices made by local authorities and citizens on energy issues. So it's a big grid because we have more than 100,000 kilometers of power line underground and in a terrestrial terrestrial ecosystem. So we are transporting electricity that is very in high tension. So we are in between the developers that produce energy and the distribution system, and also all the clients. Okay, but so RTE is an industrial operator driving the offshore energy transition. Since 2016, RTE has been the project owner for the entire connection from the offshore substation to the onshore connection point. But the first substation will be in Dunkerque, here up in the north. And today we will speak about a project more in the Mediterranean Sea, where we have a submarine power cable that is a floating cable. Sorry, I'm difficult to pass I don't want to pass my okay. Sorry, Lena, I have a problem to pass my slides. I understand. So here it is.
No, it works. Every time we ask a question, it works.
Okay, so it's just sometimes you don't want and sometimes you want. So sorry for that. So you have here you have the floating wind turbine, and or the floating wind turbines in the Gulf of Lyon connection. RTE has in charge the floating cable here, and then the cable that are connecting with the terrestrial grid. And so here we have one innovative dynamic cable to follow the movement of the float, and so you have here a representation in the yeah. I don't know if you see my my point, so you can see that you have the floating here on the cable. I hope you see what I'm
We can see it.
Okay.
Thank you, Lisa.
Okay, so sorry. So I'll try to. I think it's too warm. It don't want. It just don't want. So.
Do you want me maybe to try to share the slides?
Here we are. So the offshore connection in practice. So the submarine cable is a 3-core tripolar cable with copper or aluminium conductor. surrounded by multiple layers of insulation and protection. And it is installed on the seabed by a cable laying vessel and protected. And here you can see when it's buried under the ground, or when we have to put some arrangement to protect it. So the biofouling challenges for RTE, for future floating substations, it's to relate to biofouling in both the engineering and long-term maintenance of its submarine dynamic cable systems. But we lack of knowledge regarding biofouling growth patterns along different French coastlines, with the absence of depth-dependent in situ data. And also the design of a dynamic cable for 20-year service life is particularly challenging in 60-meter water depth due to harsh offshore environmental conditions and biofouling related constraints. So here I will present BIODHYL's contributions for RTE. So what is interesting in that project, it's that we have a technical contribution and also an ecosystem one. I'm not a specialist about technical. We are working also on environmental. So that's why this project is for RTE very interesting. So the BIODHYL project results have confirmed current practices and strengthened several key insights. So it's a lower biofouling density than Norsok assumptions. Norsok is conservative on mass, but may underestimate thickness in some cases. So we need for more accurate site-specific and depth-dependent data for engineering design. Biofouling thickness can be measured, but existing methods like acoustic cameras used by RTE remain limited and do not capture roughness accurately. And measurement on Bob Buoy deployed in Mediterranean Sea also revealed that data were conservative, so it reinforces our conviction regarding the need to deploy a dedicated instrumented buoy at least 24 months before a project begins. In the environmental part, biofouling strongly depends on depth, exposure time, location, and environment. We just have seen that with the presentation before, with highly coupled effects limiting simple engineering laws. So what one is an objective is to detect the presence and conditions of invasive alien species establishments. And what we also found interesting, it was that DNR extracted from biofouling can be used to detect fish species, and it's an innovative method for studying the reef effect. I want to thank you, Hélène Claudel, that has been working and following this project as an environmental project specialist, and Bertrand Bailleul, that is here today. So if you have a technical question, he can answer them, and is a project manager for submarine cables. So I really thank them to help me to prepare this presentation, and I thank all the people working on the project. Thank you very much.